Sometimes things are not in a form that we can solve them graphically. What do we do then? And sometimes you can't even graph them. What if we have more than two variables? Well, we come back to our old friend Friedrich Gauss here, who's going to help us. And the method that we're going to use is the elimination method. There are two rules that we can use to solve. You can multiply an entire equation. This is the whole thing. That whole equation by a number to get a new equation. And secondly, you can add and subtract entire equations from each other to form new equations, even if we've changed them, even if we've used this rule up here. As long as it's in the right format. So everything to do with that variable there, plus or minus everything to do with that variable there, equals everything which is a constant. Okay, so this is a over a, b over b, constant over constant. As long as they're in that format, we can go to town and solve them. What do I mean when I say that we can multiply the whole equation? Well, let's take this top equation here, 3a plus 7b equals 47. And we want to multiply that by 2. We would get 6a plus 14b equals 94. We could then take this equation and use that, and we can still use the old equation. Okay, let's apply the second rule to solve this, and I want to get rid of either a or b. I'm going to get rid of a, and what I'm going to do is I'm going to subtract this entire equation from this. Make sense? So 3a minus 3a is 0a. 7b minus 6b is 1b. The equals has to come down. 47 minus 42 is 5. And straight away we've got b equals 5. Okay, so far so good. Now we want to come into one of the other equations. Either one will do. So 3a plus 6 times 5 equals 42. So 3a plus 30 equals 42. 3a equals 12. We want to divide both sides by 3. A equals 4. So our answer is a equals 4, b equals 5. Both of them are solved for both of the variables. Okay. Let's have another one. So I'm going to get in the habit of naming these. I'm going to call the top one A, and I'm going to call the bottom one B. And it's pretty obvious that we have a combination that's going to work here, these W's. It's W over W, Z over Z, constant over constant. And we want to get rid of it, so we're going to subtract in this case. So 4W minus 4W is no W's. Minus 5Z minus 6Z is minus 11Z. And 22 minus 44 is minus 22. So we have minus 11z equals minus 22. And we're going to divide both sides by 11, minus 11, sorry, and we see that z is 2. Then once we've got the z equals 2, we can just come up to the top here. Let's use a for example. So 4w minus 5 times 2 equals 22. 4w minus 10 equals 22. I want to add 10 to both sides. So 4w equals 32. Divide both sides by 4. W equals 8. And we're done. Our answer is W equals 8, Z equals 2, and it's in alphabetical order, and we're done. That's how it's done. Okay. For this one here, our big problem is that it's not in the form that we need. We need it to be, say, the x, and then the y's, and then the constants. What can we do to solve that? Well, let's just bring this 2x over in this case. So I'm going to take 2x away from both sides. So I've got minus 2x plus y equals 4, and now it's in the format that we like. And I'm just going to copy this one directly underneath it. And now, do I want to add or subtract? Well, I want to add the second one to the bottom one. So minus 2x plus 2x is 0x. 1y, remember there's always a implied y there, 1 there. 1y plus 3y is 4y. And 4 plus 44 is 48. We want to divide both sides by 4. Remember, this disappears at 0. So y is going to be equal to 12. And now we have a solution, and let's put it into this one here. So y equals 12. So 12 equals 2x plus 4. I'm going to take 4 away from both sides. Divide both sides by 2. So x equals 4. And our solution is 4, 12. We would put it in that case because it's an x, y, and that's the sort of format that we like it in. Okay, now what do we do? Now we're in a bit of trouble. There's nothing there that really looks easy to solve. There's no sort of coincidence of the variables. It is in a nice format, so it's all like the x is there and the y is there and the constant terms there, but none of these coefficients kind of match up. So I'm going to get rid of one of these variables, and the one I'm going to get rid of is, so let's get rid of the y. Okay, I want to get rid of the y, and the way I'm going to do that is I'm going to multiply all of this by 2, which is the coefficient of the other one that we want to get rid of, and I'm going to multiply this whole thing by 3. And what we get is 9x plus 6y equals 21. So 3x times 3 is 9x. 2y times 3 is 6y. So 3x times 3 is 9x. 2y times 3 is 6y. The equal sign stays. 7 times 3 is 21. And then I'm going to multiply the bottom one there by 2. So 4x times 2 is 8x plus 6y. And that's why we did it. We have now the 6y over 6y. So we can get rid of this y now. And 2 times 9 is 18. So these are the same signs, so I'm going to subtract it because we want to get that to 0. So 9x minus 8x is 1x. 6y minus 6y is 0y. 21 minus 18 is 3. So x equals 3. Now we know what x is, we can just substitute that into one of these equations. Let's do the top one. So 3 times 3 plus 2y equals 7. So 3 times 3 is 9 plus 2y equals 7. Let's take 9 away from both sides. So 2y equals minus 2. Divide both sides by 2. Y must be equal to negative 1. And we're done. Okay. Let's go through these and set them up so that we could use the calculator to solve them. So we're going to go to menu, equation, simultaneous equation. There are two unknowns in this case. So now we want to set it up so there's x and y's there and the a and b's there, but it doesn't really matter. 3a, 7b, 47, and 3a, and 6b, and 42, and we solve it, and we get 4, 5, which is what we had there. And that's how that's done.